Okay, so now we're gonna do question 10. So this one has to do with knowing like the electric flux of multiple points inside a sphere. So let's get to it. So I did the work already because I thought it would be easier to kind of just explain it as I went. So you know that they each consist of a plus 10 charge and a minus 10 charge. They're on the XY plane, 1 millimeter away from the origin. Passes to the dipoles is shown. So an important thing to note here is that all these positive charges, they're all inside this, the sphere, right? So these are the ones that are going to cause an electric flux. Because remember that we count for in a Gaussian surface, we count the points of charge inside that Gaussian surface. So these are the points that we're going to be dealing with, okay? So this is a very simple problem. So we just use the equation for our electric flux, and this looks disgusting, but this is an I, the little symbol, which is just charge over your electric constant. So the charge is given here in, I think that's picocoulombs, microcoulombs. Microcoulombs, it's microcoulombs. Given in microcoulombs, so we come over here at 10 to the negative 6 to make sure that it's in actual coulombs, and I missed a sign here. Make sure that it's in actual coulombs. And then we have our electric constant, which is a constant. When we divide that, we get this number right here. It should be a 1.1. So let me fix that. So let's apologize for that. So now, this is only the electric flux of one of these positive charges that is in the Gaussian surface. So we need to find the charges for all 4 of them in the Gaussian surface. So we need to find the net electric flux of this sphere that's passing through it. And to do that, we just multiply what the electric flux of 1 is times 4, and we get this number. So we can multiply by 4 because they're the same with the same charge. So each one has the same charge. So the electric flux of each one is going to be the same. And so when we do this, when we multiply 1.1 times 10 to the 6 by 4, we get 4.5 times 10 to the 6. And that is the answer to our question.